What's up guys, I'm Kyle and welcome back to Vanover Customs. In today's video we're going to be continuing on with the Lathe rebuild project. In order to continue on with that, we're going to do another side project, and that is going to be to make a slow speed carbide grinder out of what you see in front of me. So we're going to be using this 12-volt Milwaukee polisher motor that's extra I just have sitting around, and it's going to be using these 8-inch diamond impregnated lapidary discs that I got on eBay for about $20 each. Let me bring you in closer and go over some more details. Here's a shot of these 8-inch lapidary diamond discs. A lot of guys build their carbide grinders with these discs because they're pretty cheap and they work fairly well. Most people do a 5 or 6-inch disc, but I went with the 8 so that way we'd have more surface area. It's going to make the grinder a little bit larger, which is not necessary, but hopefully, being as though these discs are cheap, my thought was more surface area would just allow them to last longer, and the cost isn't really that much different between the larger discs and the smaller discs. We're over here at the beautiful Lathe, and I just want to take a minute to talk about the philosophy of why we're making this grinder and some of the intricacies of rebuilding equipment. So I have restored most of the equipment around my shop to varying degrees, and I am by no means a professional, but I am getting better and better. One of the things that's keeping me from getting to the next level is scraping. And I finally figured that on this project, I wanted to go down that road. But like most things in machining, it is kind of a machinist inception. And what I mean by that is as you go deeper, you keep making tools to make other tools, to make other tools, to fix tools so that you can eventually use them. And this is no different. What would have been just a quick tear down and a polish up, stoning and a reassembly has now turned into me acquiring a large surface plate, making my own hand scrapers, figuring out how to do scraping, trying to acquire a power scraper, build a carbide grinder, etc., etc. And so unfortunately, I can't just go out and buy a brand new Biax scraper and a brand new AccuFinish. So I'm trying to pick the things that I can make myself to keep the cost down, and the things that I really want to spring for, most likely a power scraper, I'll go ahead and do that. So that's why we're making this slow speed grinder. And a slow speed grinder is really beneficial for sharpening solid carbide tooling, both for the lathe, but primarily they use them for sharpening scraper blades. And I do have a green wheel on a high-speed grinder, and that does work, but I really want to be able to hone the blades in so I can get the best result as I'm practice scraping. And I don't really want to buy one, and they're pretty simple, so we are going to be making one, and just making one from stuff I have laying around the shop. So let's talk about more of the details over at the bench. All right, here's the diagram we're going to be working off of, and I'm only showing this for comic relief because this diagram is extremely crude, and this is how an idea starts in my shop. So everyone does things a little bit differently, and for some odd reason, I can't tell you why, I tend to like to build things from my mind and modify them as I go. There are certain projects that I have done CAD drawings for and more elaborate drawings, but mostly what I like to do is just think of an idea, sketch something very rough in chicken scratch, and as I'm building, I make adaptations and changes. And there's some problems with that. You know, you always are going to run into some issues you didn't think of before by not being able to lay it out. But there's also some benefits to doing something where you're just making it as you go, because a lot of times I find that stuff you didn't plan ends up working out, and you can pivot really easily in the design process because you're not married to any one design. So this is a very basic project we're building. Basically all it is it's just going to be a box, and inside that box is going to be some pulleys and motors, and the motor being this. I want to be able to have an ability to take a battery out and put a battery in. In an ideal world, I would really like it to be plugged in, so that way in 10 years, if I don't have these Milwaukee tools anymore, I don't have to rely on the batteries. But I thought it would be kind of cool because it would make it really nice and portable. So if you're scraping, you could just take the box, bring it over somewhere, and plug a battery in, and that was unique. So I kind of thought, you know what, we have this motor, and that's what I want to use just because I have it, and we can make it accept these batteries, so that's what we're going to do. So it's just going to be a box that this lives in, and I decided to use a bunch of pulleys because I wanted to try using some gear reduction pulleys and use a like a timing belt, because I've never done that before. So I'm making it a little bit overcomplicated, which I tend to do, just so I can kind of learn and have some fun and make like a small gearbox. And that the other benefit is it's going to reduce the speed. This speed, unfortunately, is way too fast. It's 2,800 RPMs, and it does have a variable speed trigger, and that will be incorporated in. However, at like a slower RPM on the trigger, you do lose some power. Now it's a DC motor, so you don't lose a crazy amount of power, but at least running it at like half or better would be ideal. So we're gonna have 3, maybe 5 pulleys in there to reduce the RPM to get it to 200 or 300 RPM, which is what it should be. And then on the outside, we're gonna have a tilting rest that is gonna come up to the wheel. And I wanna make these wheels quick release so that they can be changed easier, so no nut. Kind of similar to Stefan's, where it's just magnets holding them on and a drive pin. And then what I want to do is I want to have a table that comes up here that angles both directions, mostly down, but has the ability to get right up next to the wheel so that it's like a sheet of paper between the rest and the wheel. So you could grind really small inserts without them falling down. So we're going to try to accomplish that. Kind of just building as we go. That's what I'm kind of thinking. The first step will be probably disassembling this and figuring out a way to machine the nose down so that way it could be mounted in the enclosure. So we'll start with that. All right, we got it apart and we're looking at the motor here. And a couple observations. First off, it seems that the first gear is just a straight pass through, and that's what we're going to be using. So this motor RPM is probably 2,800. The second thing I noticed is we have a really nice bearing on the front of this gearbox, which I really like. As much as I'm tempted to just take the motor off and run without the gearbox, what I do like about this gearbox is it provides good support with this really nice bearing here. So I think what we're going to do is, initially I was thinking of machining the nose cone down to do a clamp, but it's rather obvious here that it'd be easiest to make some sort of a block that has a hole in it that's slit, so we can clamp this down and then make a return so that it's like an L bracket and it sits in the actual gearbox like this. And then on the front will be a pulley of some sort, and it's already threaded for this roll lock disc, so I can probably strip this plastic off and maybe weld on a gear or weld on something and machine it down concentric. And that's going to be how we're going to start this. So we'll probably start by making this L clamp that mounts this down to the base, and then the next thing is we'll probably work on the arbor for the disc and then see how we can get from that arbor down to this shaft or this motor. We're over at the hide mac. We're just cutting a piece of this 1.5 inch wall tube or ID so we can make a clamp for that motor. Next, we'll pop a hole in this angle plate and get this welded up here to the shaft, and then we'll split it, and then we can slide the motor in and clamp down. And then on the back side, I'll just throw some quick slots so that way we can position this in the housing. I'm over at the radial drill, just punching a quick 2-inch hole in this plate. No coolant, just for video. It'll be fine. 2-inch drill bit, 80 RPMs. Small hole for pilot. The column is moving around. It will settle that down when it finds its home. There it goes. It's making a home, so it's good. Well, here's the bracket. We jammed it out in about an hour. Just had our flat bar, cut our round bar. This is an 1.5" ID. The motor's an 1.5" OD, plus or minus like 0.003. So we went ahead and welded 2 nuts. I drilled through the first one, and then we slit this so that way we can clamp down on the motor. On the back, we welded it mostly flush to the outside so that it keeps the position. And then we went and just milled 2 slots on the bottom so that way when we decide to mount this, we can move it where we want. So let's see how it works. The motor just kind of slides, and it's a nice fit, but it's not too tight, you know, easily adjusted. And then we'll roll with it right there. Let's get our Allen wrench and just gently tighten that. And there we go. Looks real nice. Nice and tight, isn't gonna rotate. We'll be able to screw it down. Very minimal deflection. That's just moving because it's rocking on the table. Because this plate's nice and thick, we can still operate the gear change, which we probably won't need to. And we didn't change anything physically with the geometry here, which is fairly efficient. We have the air ports still open in the back, and if we need to, we can slide it forward or back for alignment, and obviously side to side. So I'm really happy with how this turned out, and we were able to get here pretty quickly. The next step is either going to be to figure out what size pulley I can source from McMaster-Carr and do this arbor here, or move on to doing the large arbor that's going to accept the discs. And then once this end in the arbor is done, we can start laying these out with our pulleys and belts and figuring out what the spacing is going to be and go from there. We're over here at the blue lathe with this arbor, and I tried to disassemble it, but for whatever reason it's just real tight. So we're just going to machine this part off here. And then once we get down to that, we're gonna try to make it either by welding or pressing. We need to get a 1/4" inch shaft on the end for our pulley that we ordered. So we'll figure out how we're gonna do that. This is where the 6 jaw is really nice because it can keep everything nice and concentric. This is just rubber. Now this actually would be really good if I could take my pulley and press it on here, bore it out or whatever. This seems pretty solid, but I think the pulley that I'm getting is gonna have a hub that's too small to do that. So unfortunately, even though this would be perfect for that, I'm gonna turn this down and probably just remove this piece and then maybe bore a hole in the center so we can press a 1/4" inch shaft in. We'll see. All right, it looks like we're gonna be making another one of these, which might work out better anyway. I was trying to avoid, hopefully this isn't metric. If it is, we're kind of screwed. Maybe we'll chase the threads. Well guys, here's the issue we had. As you've seen over on the lathe, we damaged this by trying to machine it down. This thread is destroyed, and it is metric, and it is an unusual thread. It's, I don't know, probably M8 or 10, but it's a 0.8 pitch, which is a little unusual for that size. Of course, they're the manufacturer, they can do that, no problem. I was a little discouraged for about 20 seconds and then realized this is a machine shop. We make our own rules and fix our own problems. So what I did is I disassembled the gearbox and got to our little stub shaft. And so what if the pitch is wrong? We have options. We can either drill this out and press in a 1/4" inch shaft or turn it down to a 1/4" inch. We can retap it. There's many things we can do, and so we'll address that. Many of you guys might be thinking, man, you're going through a lot of work to save this free item and make it work, and you'd be right. But that's kind of the beauty of working around a design constraint, and in this case, the constraint is the part we already have. Although, from an economic standpoint, it doesn't make any sense. We go through all this work. If this motor dies, whatever we're doing is kind of useless, and that's true. However, it's really nice from a design standpoint because it forces you to be creative and it forces you to learn, and that's what I do enjoy about this type of project. So we have an issue, and instead of give up and buy another motor, what we're gonna do is we're gonna figure out a way to make it work. And in this case, it should be pretty easy. So most likely what we'll do is we'll drill this out. I'm fairly certain this is hardened just based on looking at it. So probably what I'll do is I'll bore it out on the lathe and get a 1/4 inch shaft. That looks a little larger than 1/4 inch, but I'll machine down a shaft, which is a nice press fit. So it's not gonna go anywhere, press it in, and then machine it down to 1/4 inch, and then we're done. And then we don't have to do anything with this. This shaft will already be set up with our 1/4 inch shaft already installed. So we'll try that and go from there. Off camera, we went ahead and made a shaft and got it pressed in and got the gearbox reassembled. I took it over to the mill and machined a flat on it. I made this shaft out of stainless, just figured it would give us a little bit extra strength and work really nice. I did oversize this by 1/1000, so it's 251, and the pulley itself is supposed to be 250 for a press fit. So if we need to run a reamer through the pulley, we will, but if nothing else, that'll give us a nice tight fit, and then the flat for the set screw will just secure it. So we can move on to the next step. Really quickly, we got some parts in, just want to review them real quick. So we got our smaller pulley pushed onto the shaft. It was a nice tight fit, but we tapped it on. 2 set screws holding that, should be nice and concentric, so that's done. And then we got our nice bigger pulleys here, which will reduce the speed nicely. And then our 2 little baby timing belts. These parts are really cute. And then we got a bunch of bearings up here that we may or may not use, and some 1/4 inch shafting that I purchased, because the only 1/4 inch rod that I had is just like hot roll, and it's pretty non-standard size-wise. One more thing, I did find this skateboard wheel, and it has a larger bearing. I changed the design slightly. So originally, we're gonna be using this for the front bearing, and we still are. And I was debating about using these for the support bearing in the rear, and they'll be fine. But I found a bigger bearing, and just the main benefit there is the rear of the shaft doesn't need to be as small in diameter. So hopefully it's just gonna make it a little bit easier to machine, because it's not gonna be wanting to flex while we machine it. So those are the parts, and I'm gonna move on to the drawing. For the next part, I wanted to make a sketch. I figured, hey, I could probably force gut my way through it, but a sketch would just kind of minimize error, and it is a little bit unnecessarily complicated. The reason being is I see a lot of these slow speed grinders and the wheels wobble quite a bit, and that's fine. It's such a slow speed, it wouldn't really change much, but I would really love to see if we get the run out down to 5/1000 or less. So in order to do that, I want the face here, or the face plate, to be concentric with everything else. And the way we're gonna hopefully do that is by using a center on both ends, and to try to do this either in one operation or run it between centers to make sure that even the back face here, where the bearing runs, is concentric to the face where the plates attach. So the front has a nice little cutout for our aluminum plate. Our aluminum plate will be pressed in, and that will receive the magnets. And then the actual 8-inch disc will be flush to the front of this. And then we have a nub that exceeds past the aluminum plate for the center of the grinding wheel to register on. And then we just have a 2-inch section for weld, so that way we can attach our shafting material. And then we have a section for the bearing, which is 17 millimeter, which is that bearing we're gonna be using. And then we went ahead and bumped up our pulley size. The pulleys are 1/4 inch, but I bumped it up to 1/2 inch just to add some additional rigidity during the machining operation, and we'll bore out the pulleys. And we have a lot of meat on the pulley, so that'll work out good, and we'll put a flat on that. And then the back side, I was gonna use a 1/4 inch support bearing like I showed that I purchased, but because I did find that 5/16 bearing from the skateboard wheel, we're gonna make this section 5/16 just for more rigidity. We're gonna knock this out by starting by welding this to our plate, and then we'll take it over to the lathe and start knocking this part out. We got our weldment up here in the lathe. I'm gonna just come around the back and clean up this weld. It's just visual, not really much else than that. We got our lathe tool turned upside down. We're gonna run in reverse and just clean up that weld bead. I'm gonna be honest, the run out on this is really not that bad at all. I'm kind of shocked. We'll just keep getting this cleaned up and move on from there. Now that I got this chucked up and I seen how nice and true the front is running, I think I'm gonna switch the way that I'm gonna machine this. I'm gonna machine the front and the side and get all the operations up here done, and then we'll flip it around and we'll indicate off that machined surface. And then once this machined surface is running true, we'll finish out the back, and that should keep everything nice and concentric. Just gonna take 100 thou. It is taking a cut. The insert's definitely in rough shape, but we'll hopefully get past this rough area and swap it out. All right, we got a new insert swapped out, and we're gonna make some better cuts. Much better. All right, let's just take 150 thousandths. There we go. Now we're getting work done. I think we might have a flat spot in there even still, but we'll check it. I'm gonna take another 150. Well, I think if anything, this is proof that our weld is a good weld. This is probably more force than it's gonna be taken when we're grinding. Running 1,000 RPMs just for the center. 725. We're gonna come in 20 thousandths. Oh, that's nice. That's very nice. Now we're gonna come in here and tree pan out some area for the aluminum. So we'll probably use a boring bar and do most of it, and then if we need to make a tree panning tool to finish it out, we will. All right, went ahead and made a tree panning tool over here off camera. We're gonna come in here and get this cleaned up. I roughed it out with the boring bar, and we'll get it all finished out to finished size. I'm gonna slow down the RPM because we're running high speed, 275 RPM. We're just taking a finish cut here. Nothing too crazy, 5 thousandths, real slow RPM. We went ahead and got this aluminum circle cut out. We're gonna use this to press into that tree pan hole. I was gonna machine this to size, but I thought it would be interesting to use my circle grinding jig, and that would allow me to easily take this off, bring it over there, test fit it, and bring it back. So I got my measurement, and let's get sanding. All right, we went ahead and got this finished out. It's finishing out at 5.883. The hole is 5.881, so that's 2 thousandths, maybe 2.5 thousandths oversized. That's a little on the tighter side, but what we're gonna do is, since this is aluminum, it's very affected by heat, and I'm hoping that's gonna help us out. We'll put it in the freezer, then we'll take some lunch, come back, and then we'll try to shrink it a little bit more and hopefully press it into place. All right, we got our part chilled off. And it looks like it's still a little bit of a tight fit, which is fine. We got our tailstock here. We use as a press. There it is, look at that, perfect fit. All right, we got this pressed in there. Next, we're just gonna get this machined off. I got a piece of high speed I got polished up, and we'll see how that does. Nice cut. Nice sharp tool for aluminum. We're just gonna let it. We're just gonna punch a hole in the center for our pin. Using a 3/8 end mill. All right, we have our pin here that we just made up, and it should be a decent press fit. I made it a little thinner on the front. We'll just use the tailstock to push it in. Just chamfering this. All right, we got our part chucked up in the blue lathe. I have it over here because I want to get this roughed before we go ahead and finish everything out. With there being stresses in the metal from welding and just joining material, and even when you machine, things change. So I want to get this roughed and get it down to size, and then maybe we can run it between centers to finish everything out. We do have a center in the end here and then in the end here, so we're gonna work off that. This Bison 6-jaw chuck is pretty dang accurate. It may be accurate enough for us to work and finish out in this orientation, we'll see. I made sure all the jaws are cleaned, and it is sitting firmly against all 6 jaws. And when I had it over there in the 4-jaw chuck, it was within 1/1000th, so it might be good enough. But nonetheless, we'll get it roughed out and we'll see how we finish out. and maybe we'll finish over here, or maybe we'll do it between centers. We're gonna start out by just turning down the whole shaft to the next diameter. This is supposed to be 2-inch nominal, doesn't really matter. It's a little undersized, makes no difference. So the next dimension is for our 17 millimeter or 0.699 bearing. So we gotta hog a lot of material. So that's what we're gonna do next. And actually, I'm gonna run a CNMG instead of that, just to do some good hogging. It's a 432, we'll touch off, bring it up to 1200 RPM, zero the feed rate. Let's start with 100. Look at that, working nice. Pretty decent. There it goes. Let's take 200. Let's see if it likes that a little better. Yeah, it's definitely liking it. This stuff is just stringy. The machine's working real hard, but it's doing it. I think it's this insert. It's not doing a good chip formation. But we'll let it finish out. All right, we got a new insert. See how we get on with this. Yeah, that's better. That's what we're looking for. I think that's 150 thousandths. All right, I'm looking at the setup, and I actually think that doing this in this operation is going to keep it accurate enough for what we want. So instead of turning between centers, I think we're going to finish it out right here. I'm going to go ahead and let this cool down, and then we'll come back here in a minute and we'll finish. We just got to take 30 thousandths off this surface, and then we'll start working on the steps. $679. We're just going to take 9 additional thousandths. Not bad, not bad at all. 2 to 3 thousandths, very livable. We're over here at the milling machine. We got our arbor set up. Everything's turning out real nice. One of the last steps on this part is to go ahead and put the holes around the perimeter for the magnets. So what we're gonna do is, I didn't really want to glue these magnets in, but what I wanted to do is try and press fit these magnets. so that they would be a nice tight fit. So since I don't have a reamer that matches the size of the magnet, what I've done is I'm using a small, I think it's like a Criterion style boring head, and I've adjusted it on a scrap piece so that way it's like a 3 or 4 thousandths press fit on the magnet. So we're gonna go around here and put a bunch of holes at the same depth, and then we'll go and get them magnets pressed in. All right, now that I've touched off, I went ahead and zeroed my DRO. We're gonna come up 130 thousandths. There we go, there's our first hole. All right, I'm just gonna take our magnet, get it up here, make sure it's not gonna drop in. And then also just test this with a depth mic and see if it's where we want it. All right, we're gonna continue on around and drill 12 different holes at 30-degree increments. All right, it's time to go ahead and press in the bearings. Now, if you notice, there's some numbers written around the perimeter. I did come in here and stone this, ruining our perfect finish. Doesn't matter. We're trying to get something that works here. And then I took a measurement with a depth gauge on all of these, and they were within about 5 or 6 thousandths. They weren't perfect because there's some deflection in the part because of the way I was grabbing it. But after reviewing the magnets, the lowest diameter is still about 4 thousandths below the magnet. So if all goes well, all these magnets should be below the surface, and I don't think 7 thousandths height difference across the spectrum here is gonna make that big of a difference. So let's get these guys pressed in. I've already done a demo on these. It's real nice because the magnet can kind of just stick to the press. There she is. Just drive her home. Doesn't take much force. And there we go. Now actually, I think we're a little proud here. I think it's because my ram is bottoming out, so I'm just gonna get a socket and get it on there so we can get it flush. There it is, just that extra bit. This actually works really nice because it'll hold our socket. And looks like we can actually just press it with the hand wheel. All right, we're gonna test a wheel on this, see how it fares. Ooh, that looks real good. That's a real nice fit. Oh yeah, you can see the wheel flex when I try to take it off because it's held down so good. Wow. I'm gonna go ahead and mill a slot here so that way I can get a screwdriver in there and take the wheels off. This arbor turned out really nice. We have a nice relief back here so we can pop this up. And these clip on with a lot of pressure. Nice, satisfying clip. We got 12 magnets around the perimeter. We have our nice relief milled in here, and this is nice and flat. We got our register in the middle, which is 1 thousandths undersized from the bore so that the wheels go on nice and easy. And then we have a 1/4 inch pin, and then I drilled a hole that is 1 size larger so that way it goes on nice and easy. I figured doing it really tight wasn't really that important because I want to be able to get the wheels on and off easily, and a little bit of movement in the wheel is no problem because when you start it, it's just going to move maybe a 30-second and set. So I'm really happy with the way the front turned out. The back, we got it machined. Here's our weld relief. We got our first little spot there for our 17mm bearing. We have our nice spot for our pulley, which we bored out. and then for the back 5/16 bearing. So now that we're done with this, we're gonna move on to the next part of the build and make a little housing for this and a bearing mount. Okay, if I'm being honest, things are getting a little bit out of hand here. We are taking this to a level I wasn't expecting to take it to, but hey, it's turning out really, really nice. We made this overkill housing off camera, and it's gonna house this wheel, and I have a step machined in the outside, so that way when we put our sheet metal, I can actually bring it right up to this rim, and it's gonna have everything real flush. It's gonna allow me to have the wheel protrude from the housing, maybe like a 1/16 of an inch. That way everything is nice and flush on the front of the housing, and it's gonna look really, really nice. And this housing will keep the dust out of the inside if there was any. It's turning out really nice. So let me show you the back of it. Pretty simple. We have our bearing in there, and then we're gonna have our support bearings on the end and our pulley right here. Overall, nothing too crazy. Let me take it apart here. It's a real nice fit on the bearing. Let me set that aside so you can kind of see. Went ahead and just welded a plate on the back of this, and then we bored out the ID for the bearing enough so that the center part could come through on the back, so we can get a retaining ring back there. And then we did a press fit and used some retaining compound to make sure that won't come out. And then just kind of cleaned up the inside, so that way the wheel runs really concentric to this housing and everything looks really nice. Again, completely unnecessary, but hey, it's turning out really, really nice. And when it's done, it should be real nice and overkill and look real sharp. We're making a back cap here for our bearing support. And you can see I'm getting better at my TIG welding. I went ahead and did this off camera so I could focus, and I'm really happy with that. So what we're gonna do is we're gonna bring this back here, and I want support on the bearing. So instead of do a bearing like pillow block in the actual housing, which I was gonna do originally, I wanna incorporate the rear bearing support into this housing, so that way no matter where I mount this guy, we're gonna be good. So I'm making this, we'll go ahead and deck the back and throw a pilot hole for a 5/16 bearing. Then we'll take this and we'll weld it onto the back, and we're gonna cut out half of it so that way we can access the pulley and the belt, and then we'll bore through this concentric with this, so that way we're all good to go. I am super excited. We've been working on this part for way too long, but the hard work is paying off. We finally got the rear support and the bearings in, and check it out. Look at the run out on that. 2 thousandths maybe total, so 1,000 each side. Absolutely amazing. It's a nice tight fit on the bearing. You can kind of see the resistance there. It's not super free spinning, but it's not too hard to turn. Really, really nice. This kind of gives you a shot in the back in the window as the shaft's turning. All right, so we're gonna mount a gear over here, the part with the flat spot. It's fully supported in the back with 2 bearings, incredibly overkill for this application. So we'll have just enough room to get our pulley. You may be asking how we're gonna get the belt on there. This shaft pushes out, so we'll push it out. I'm gonna go ahead and machine a C-clip ring groove there, so we can do a C-clip to keep the wheel from popping out. So when we go to assemble this, we'll put the belt on here first, slide it in, then do the pulley at the same time, and then lastly do the C-clip. Should have plenty of room to work. And then once that's done, we'll throw the belt on the bottom section, which will have a little bit more clearance. So this should work out really nicely. This will allow me to mount this housing inside of a case, and the orientation is not that critical because it's already supported, and this is one assembly, which is really nice. So the idler assemblies and the motor are gonna be way more simple, but just getting this all in one piece keeps everything nice and true, nice and stout, and just really easy. So I'm glad that this worked out well. We're over here at the hide mech. We're just gonna cut off our bar for our next section. All right, we're getting ready to cut some slots. I went ahead and found the center and then offset each side 800 thousandths. Onto the other side. Taking this like maybe 100 thousandths at a time. We're gonna punch a hole just for clearance on the back. We're using an annular cutter here, nothing crazy. This hole isn't really necessary. I'm just doing it for service so I can get to the back of the Arbor. We're gonna throw a clearance hole here so we can bore it out. Come in with the 1 inch. I'm just gonna bring it all the way through to the end. We're over at the press and we're getting ready to press this shaft in. I ended up undersizing this hole or oversizing it by a few thousandths. So I went ahead and knurled this just so we can get a nice tight fit. There we go, there's our knurled section to make it a nice tight fit. And that is a tight fit, I can tell you. I switched over to our compound mode on the press, so it should take less effort, about half as much. And we're gonna continue to keep pressing. Oh yeah, gotta love the compound mode. I'm not sure that we're gonna be welding this. This is a really nice press fit here. There we go. Got it pressed in. It's a nice press fit there. This is kind of cool. We're boring this out with a really long end mill. Kind of cool little trick. You don't have a boring bar long enough. We got the back spacer welded up. Not bad, my TIG welding is getting better. This might be the limit of what I'm gonna be able to do without a turntable, but overall, really happy. Well, it's come time to test this bad boy out, and I've already tested it, it does work. I'm gonna show you how well it works, and then I'll flip you around to the back and show you what modifications we made to get to this point. There we go, plenty of torque, nice and strong, all off that little motor, and all off a little 12-volt battery. Pretty impressive. That's the beauty of gear reduction. Let me bring you around to the back and show you what we look like. Well, here's the back of it. I did some of these parts in the previous couple shots, but I spent a lot of time working off camera just to dial this in. It's a lot of trial and error. And here's the system we have. So we have this back plate here that's adjustable. There's slots on both sides, and then we added this screw so we could dial in the tension. There's a belt under here that you can't see. It's blocked from this assembly, but it comes under here. And then on the top, we have the exact same feature. We have slots here, and I just adjust the tension on this one manually, but I do have a key slot milled here so that I can slide this in and out and it keeps it nice and parallel. And then here as well, we have an adjustment up and down so we can make sure these pulleys are in alignment. I also have a key slot milled on here, and then 2 slots there as well. So overall, this is pretty overkill, but what I wanted to do is make it somewhat easy to adjust and manipulate, so that way when we're working with it, if there's an issue, we can go back and correct it easily instead of having to re-weld something. So if I find that these are out of alignment, all I gotta do is open the case, loosen these, tweak it a little bit, and then we're good to go, and it takes a minute or 2. So I'm really, really happy with that. This idea kind of developed as I went, which is the beauty of building things the way I do. I wasn't planning on building any of this off of the base. I was gonna make individual pillow blocks and all kinds of stuff and mount it to the case, but this really came together because this base is so rigid, number one, and the other beauty of this is because I'm building it off of here, I don't have to worry about alignment issues with the case. I know that this is square to this is square to this, et cetera, et cetera. Now, there can be a lot of misalignment with these pulleys and it will still work fine, but by doing this, I can mount this case in the housing, and the housing doesn't need to be square, it doesn't need to be a certain shape. It's just basically a case for the main component, which is this, which is really, really nice. So we know it works, I tested it, Really all we got to do is build a case, sort out the wiring, and do the table, which will be a little bit more complicated, and we should be good to go.